Hello. Welcome back to the channel. In this video series, we are going to review the principles and practices of commercial construction. This is about chapter 4, material movement, excavations, and equipment. And as you remember, there are 16 chapters, so this is video 4 of 16. So this is a pretty long chapter and it covers such aspects as effects of soil types on excavating equipment, removing groundwater, general and special excavations, estimating amount of materials to be removed, cranes, excavating machines, trucks, choosing excavation equipment, then protection of excavations, excavation wall bracing, protection of adjacent buildings, rock excavation. So let's dive deeper into that. So site excavation prepares the building site for future construction activity. You already know that. And the initial site preparation can begin with the removal of all topsoil and stockpiling it for later use as landscaping materials. So the building site may need enhancing to ensure proper drainage around the building and in the parking areas, and trenches for services must be dug. In areas where cold temperatures affect the soil, foundations must be placed below the frost line. In many locations, sufficient soil bearing values are found only at some distance below the surface of the ground, and the overlying material must be removed before the placement of the building footings can proceed. On restricted sites, parking levels placed below ground require, in some instances, an excavation several stories deep. Areas below grade that contain shops, services, transportation access, and pedestrian links to other buildings require extensive excavation. So effects of soil types on excavating equipment. We always need to remember that the type of soil at the building site will be the major factor determining the size and type of excavating equipment needed for the job. So for those soils that are loose or non-cohesive, such as sand or gravel, for instance, a hydraulic excavator can be used effectively to excavate and load the excess material onto trucks. In many instances, the initial removal of the topsoil is done with a bulldozer. So if the soil must be removed from the site, a loader is used to load the material onto a truck. So, and as always, I highly recommend to go to the textbook because there are a lot of beautiful images that you can see and that will actually make the picture clear. And if you don't know something, if you don't know how something looks, I highly recommend to Google it or just go to YouTube and ask like how the loading of boulders work or something like that, and just like how a crawler crane is equipped or something like that. So please always make sure that you are familiar with that. You don't just read about that or listen about that. You always back it up with the image. So, and we are moving to removing groundwater. So one serious problem encountered regularly during digging operations is the presence of water in the excavation. So when and this may be caused by different reasons, by rain, melting snow, underground flow, or the fact that the water table in the area is high. And water table is what is that? That is the normal level of groundwater. And if that level is close to the surface, excavating will allow the groundwater to seep and collect in the excavation. And you already know that if the water table is high, that means that could be some additional expenses for pumping it out. So there are three principal methods of removing or rerouting intercepted groundwater. One is to pump, and that is useful in removing collected rainwater and runoff, or in removing the water from intercepted underground flow. Then the next one is removing the next method of removing groundwater, intercepting surface flow, and collecting runoff is by use of perimeter trenching. This method requires the excavation of a perimeter trench or ditch, especially several feet lower than the foundation bearing level, and using larger pumps to pump the water from the ditches. And the third method is to lower the water table selectively in the area which the excavating will take place. This is done by a dewatering system, which involves inserting into the soil a series of well points, usually connected by a pipe manifold around the area, and extracting the water by suction pump. And again, there are pictures, sections, and beautiful explanation of how it actually looks like. So for example, there is a 2-inch self-jetting well point, and I highly recommend to get familiar with that, as well as the well point system, and that's the profile here. So when we talk about general and special excavations, what is important to understand here? General excavations include all of the work other than rock excavation that can be carried out by mechanical equipment. Special excavation includes the work that must be done by blasting, by special machines, by hand, or by a combination of both. And the contractor should be fully aware of the types of excavation that must be dealt with to estimate the cost properly and to ensure that the right kind of equipment is on hand to do the best job. So we are moving to the next section, and that's the estimated amount of material to be removed. So it must be estimated before an excavation is begun, and this should be based on the cubic yards of material to be dug and hauled away. So please remember, so when the soil is disturbed from its original condition, broken up, moved, it experiences a change in volume. Usually it's increasing. So in general, the soil will swell or bulk between 15 and 20%. And there is a chart here in the textbook. You can see the soil swell percentage. And we see that the stone, the blasted stone, actually swells from compacted state up to 50%. So the lowest is sand and gravel, that's 12%. Clay is 25%, and loam is 20%. So please be familiar with that. So in its undisturbed state, the soil, the volume of the soil is known as bank cubic yards or bank cubic meters in the metric system. And then the resulting volume of disturbed or excavated soil is measured as a loose cubic yard or loose cubic meter. So if the soil is cohesive enough, or if some means of supporting the sides of the excavation are to be used, the compact volume to be removed is simply a matter of length times width times depth. But there are some variations. And there are a few examples here, a few problems with the calculations with the, so it's like problem and the solution to that. So I highly recommend to just take a look at that to know how it's calculated. There are a few methods. One is a little more simple and one is a little more complicated. And there is a table here. That's the formula for common shapes, which you are, I'm sure, familiar with. And another little problem with the solution. So that is something that I would highly recommend you take a look at. And we're moving to cranes. So before discussing machines used specifically for excavating, it's appropriate to deal with some aspects of the crane, a machine that has been indispensable on the construction side. There are two basic variations. So one is stationary crane and one is the mobile crane. So the stationary crane, more commonly known as the tower crane, comes in two options. One, the tower of the crane is supported at ground level on a concrete foundation. And the second type is the tower is supported by the building frame, and as the building rises, the tower hoists itself up the building frame using the lower floors of the building for its support. And please take a look at that. I'm sure you've seen those tower cranes in the urban environment. That is what is used on the most urban sites, and also some other larger objects. So there are different variations of mobile cranes, and to improve the mobility of the crane from one side to another, truck-like carriers with rubber tires and an additional cab were developed to allow the operator to drive the crane from side to side, and it makes the crane fully mobile. And also there is a crawler crane that has a base capacity of like more tons than the rubber tire crane. So take a look at the pictures, be familiar with that, be familiar with the brands, and compare and contrast, because sometimes the price difference is quite significant. So when we take a look at the crane principles, a crane consists primarily of a power unit mounted on a carrier with a hoist, a boom, and control cables for raising and lowering the load and boom. And you can see all the beautiful graphics here. Please, 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 I cannot just say it enough. Please back the video up with the text, with the images. So in general, the load capacity of a crane depends on the following: stability of the footing, strength of the boom and its supporting hardware, hydraulic pressure limits for hydraulic cranes, counterweight, quadrant in which it's working. And that is something to remember. And this is how you need to calculate the weight load that the crane needs to carry. And there is a nice little chart here showing the crane tools. So it shows the digging tools, hooks, grabs, and bulk material tools. So please be familiar with those and with the names as well, because sometimes you really need to specify something for a very specific job, and you need to know which one you should use. And we are moving to the excavating machines. So the past several decades have brought great advances in the design and quality of excavating equipment available to excavating contractors. So let's take a look at the dozers and graders. So a dozer can be defined as a track-mounted tractor equipped with a blade with a special attachment on the back known as a ripper. Large dozers are used for clearing and leveling uneven terrain in preparation for the site construction of a roadway or a building development. A grader can be considered a light-duty angle dozer. And again, a lot of pictures. Please go back and check them, and you can see the difference, because there are some different aspects here. Scrapers. Elevating scrapers have established an important position in the earth-moving field, particularly when large volumes of materials must be excavated and deposited some distance away. So a scraper is a combination machine that can load, haul, and discharge material all under its own power. And usually it has large tires, and actually it's pretty fast and highly maneuverable. Hydraulic excavators. Although much heavy digging and loading in the past were done by the power shovel, these mechanical monsters have been replaced on the construction site by new efficient machines commonly known as hydraulic excavators. So using a pull-in action rather than a push-in action on the bucket, powerful hydraulics instead of cables operate the boom and bucket. And please, again, just go take a look at the pictures. There's an L excavator, power shovel, and other machines shown here. So, okay, let's move to the drag line. So one of the attachments used on a crane boom is a drag line. So what is that? That is the attachment that consists of a dragline bucket, hoist cable, drag cable, and fairlead. The machine is operated by pulling the bucket toward the power unit and regulating the digging depth by adjusting the tension of the hoist cable. So again, a lot of nice graphics. It will definitely make the picture clear for you. So please make sure that you get yourself familiar with that. So another one that we need to take a look at is clamshell. The crane boom is often used with a hinged bucket called a clamshell for vertical excavating below ground level and for handling bulk materials such as sand and gravel, which is very heavy. So we are moving to the trucks. And of course, that is something that we'll always see on the construction site. So again, there are a few different types, and trucks may be classified in a number of ways, including the following: size and type of engine, number of gears, 2, 4, or 6-wheel drive, method of dumping, capacity, net weight, and gross weight. So also manufacturers' computer programs relating vehicle mass, coefficient of traction, and gradability to rim pull values and speed provide specific load hauling data for each piece of equipment. Cycle travel time is based on the attainable speeds of the truck for loaded and unloaded conditions. There is a formula to understand that. That's the equation. So please refer to that when you do the calculation, so you load the truck accordingly to its capacity. So, and again, there are a couple of examples here, a couple of problems with the solution. So please, please, please refer back to the textbook. That will be your little cheat sheet when you do the calculations. So when you choose the excavation equipment, a number of factors must be considered to do the job most efficiently. The first point to consider is the volume of material to be removed. This will influence the size of the machines to be used, and the depth of the excavation will determine the height to which material must be lifted to get it into trucks. So many factors have a bearing on the type and size of machine that will be considered. The major considerations are the following: type of materials to be excavated and hauled, site conditions, distance of haul, time allowed for job completion, and contract price. And we already know that sometimes contract price dictate the rest of the factors. So again, a couple problems with the solution. So for example, here's the hourly shovel handling capacity. There's a chart that you can use for solving some of those problems. And please be familiar with them because you will be using them. You will need to understand where to find that information and what actually units are used to do the calculations. And we are moving to the protection of excavations. So that is important to take steps to ensure that sidewall cave-ins do not occur, necessitating costly work in removing fallen earth or causing damage to forms or injury or death to workers. So the amount of protection required depends on the type of soil being excavated, the depth of the excavation, the level of the water table, the type of foundation to be built, and the available space around the excavation. So please check back with OSHA and local ordinances regarding excavation protection, just because it may vary, because soil types are different from, and they depend on a lot of different factors. So please check with the local jurisdiction and with OSHA what the requirements are. So again, a few pictures here, such as freestanding excavation walls and some other trench drains in the deep excavation, how that is organized, and also how timber planks are used in the protection of an existing building foundation at the edge of a new excavation. So that is something that we always need to consider when we work on a very tight site that is adjacent to the existing structures. So most methods used for supporting the earth walls around the perimeter of an excavation involve a system of sheeting supported by vertical supports. So the basic systems are interlocking steel sheet piling, steel soldier piles with horizontal timber sheeting, and concrete slurry walls. So only in very shallow excavations would ordinary plank sheeting will be used. So please remember that it's better be safe than sorry. And here you can see the examples of the interlocking sheet piling, then the steel sheet piling, and the other types such as steel soldier piles and horizontal timbers and concrete slurry walls. So please be familiar with that, how that is constructed, what the details are. So please just make sure that you familiarize yourself with that. So the excavation consists of a trench with a choice of digging equipment depending on the soil involved. In soft to medium, hard, loose, or cohesive soils, the popular digging tool is a clamshell bucket. The alignment of the trench is controlled by two concrete guide walls, about 1 foot wide and 3 to 5 feet deep, spaced apart the width of the trench and placed at grade level. So as materials is excavated from the trench, bentonite slurry is immediately piped in, with the level of the slurry being maintained close to the surface at least 2 feet higher than the highest level of groundwater to produce a positive static pressure on the walls of the excavation. So that's a little bit about the slurry walls, and please refer back to the textbook. So let's talk about top-down construction. A recent innovation used in conjunction with the slurry diaphragm wall method is the concept of top-down construction. Several variations of this method have been used depending on site conditions. However, its execution is based on a combination of foundation engineering and mining construction techniques that allow for the simultaneous construction of the superstructure and below-grade excavation of the building. So there is a description of this top-down construction, how that is done. So the building perimeter is enclosed with slurry walls. Then before excavation begins, a mud slab is poured at grade level on which the ground floor structural slab is poured. And also there are a few other steps. Please just I highly recommend to go back to the textbook and get yourself familiar with those images. So several advantages can be realized using this approach to the excavation of deep basements. Where the site is surrounded by other buildings, the procedure minimizes the possibility of settlement during open excavation. The slurry wall can be built in one continuous operation from existing grade, reducing construction time. And the slurry wall provides its own waterproofing and allows for the removal of water within the building perimeter without disturbing the level of the water table outside. So let's move to the excavation wall bracing. So that restraining system is used to stabilize the sides of an excavation. The walls will have to be braced against the lateral pressures exerted by the surrounding soil and water, as well as any superimposed loads due to construction equipment. So, and again, government agencies such as OSHA, the National Bureau of Standards, the Bureau of Reclamation, and the U.S. Army Corps of Engineers provide guidelines for the proper selection, design, and construction of all shoring components. So, shoring for trenches. Trenches are used for the placement of building services such as water, sewer, and electricity. In some instances, reinforced concrete service tunnel used to enclose the service lines are constructed in a trench. So trenches are relatively narrow and deep, and they pose a significant hazard to site personnel who must work in the confined space. In the event of collapse, injury and death to individuals working in the trench are common occurrences, unfortunately. It is an understatement to say that proper design and construction of the shoring and bracing are of the utmost importance. And here again, you can see the timber shoring for trenches, how that is designed. Also, there are portable steel shoring sections that can be moved from side to side. So let's talk about a little bit about internal sloping braces. So while lateral restraint is required quickly or for a short period of time, a practicable method of supporting the walls of an excavation is to use internal sloping braces. Steel or timber columns spaced at intervals around the perimeter of the excavation are held vertical by one or more of such braces. So, and there is also horizontal diagonal bracing and trench boxes. So I'm sure you have seen all of those at the construction sites. So tiebacks, let's talk a little bit about that. So with the development of rock and earth tiebacks, internal bracing systems have been replaced to a great extent with tieback bracing systems. Although they usually are more expensive to install, the main advantage of a tieback bracing system over internal bracing is that it provides a clear working space within the excavation. So there are no like horizontal planks connecting the two walls and pushing them back. So rock tiebacks, so those are 4 to 6 inch pipe that are driven through the earth overburden at a 45 angle until rock is reached using conventional drilling equipment. Then earth tiebacks. Earth tiebacks are used where no rock is present for anchorage. They are more difficult to use because of the lower anchorage values, but they use a flatter angle of penetration, 15 to 30 degrees from the horizontal being common, comparing to the 45 angle rock tiebacks. So there are two types of earth tiebacks, large diameter and small diameter, and please take a look at those here. And we are moving to the protection of adjacent buildings. So when you work in the urban environment on the construction site that is in between the buildings in the city, it is necessary to carry the excavation for a new building right up to the foundations of one or more existing buildings. So temporary support may be provided by shoring or needling if the building is relatively light, whereas permanent support is provided by underpinning or extending the old foundation down to a new bearing level. In case of heavy buildings, underpinning will usually be installed during an early stage of excavating without shoring or needling. And so shoring is the simplest method of providing temporary support for an existing building. But it's only useful for light structures. So needling involves the use of a needle beam that is thrust through the wall of the building being supported. The inner end stands on solid blocking while the outer end is supported by a post resting on a jack. So again, there is a beautiful section here. Please make sure you get familiar with that. Underpinning, that is the provision of permanent support for existing buildings by extending their foundations to a new lower level containing the desired bearing stratum. So there are different types such as leg and leg underpinning, pit underpinning, jagged cylinder underpinning, and pretest underpinning. So please be familiar with those. And we're moving to our last section here, that is the rock excavation. So just always remember when you need to do the rock excavation, that is going to be very expensive just because blasting is expensive and hauling heavy rocks away from the construction site is expensive too. So the techniques of blasting have been made possible through the development of gunpowder and the refinement of explosives such as dynamite. So blasting principles. Explosive commonly used in commercial blasting are practically all solid or solid liquid mixtures capable of rapid and violent decomposition with resultant conversion into large volumes of gas. So, and the decomposition of a high explosive such as dynamite takes place with extreme rapidity, whereas a low explosive such as black blasting powder decomposes more slowly, simulating rapid burning. So as a result, high explosives are called detonating explosives and low explosives are referred to as deflagrating explosives, excuse me. It's a mouthful. So, several types of dynamite exist, the common ones being straight, extra, or ammonia, gelatin, and permissive. So this is something interesting here that is not just for the construction purposes, it's used in other industries as well. So, and again, a few beautiful diagrams here, how that is constructed, where it's placed, and actually what is important to remember here. For example, there's a section through loaded and stemmed hole, and the leg wires are shown here. So, and also what we need to remember here, a variety of patterns may be developed by the use of explosion, and the basic patterns are illustrated here because sometimes it is not predictable how it's going to end up. So please just familiarize yourself with that. And also, of course, we need to mention here that safety is a prime factor in blasting operations. And there are 15 general safety rules to practice when handling explosives. Smoking must not be tolerated in the blasting area. Only hardwood or non-spark pokers must be used to pierce cartridges. Circuits should always be checked before firing. It must be made certain that the area has been cleared before firing a shot. Shunts should always be used when setting up an electric circuit. When electrical storms are in the area, all electric blasting should be stopped. Only non-sparking tape should be used for measuring hole depth during loading. The shocking of dynamite should be avoided unless absolutely necessary. Inventory should be taken before and after firing on a shot to guard against mislaid explosive and caps. Only blasting galvanometers should be used for testing the circuit. Loaded hole areas should be clearly marked with appropriate signs. Piles of cartridges should never be left beside a large diameter hole. Holes must be cool prior to loading, and they should be checked. The primer cartridge should never be forced into a hole and should never be attempted. Storage of dry cell batteries should never be used to activate electric blasting circuits. And that actually wraps up our chapter 4. Thank you so much for watching. I will see you in chapter 5. Thank you.